All right, boys and girls, my name is Cesar. We are going to start learning about binary conversion and how to successfully do it. So let me just validate I am sharing the correct screen. I need to share a screen too. And let's start with this topic. So basically, when we are talking about binary, the ones mean turn on and the zeros mean turn off. We're going to understand this in a bit. Before we start calculating subnets and talk about IP addressing, let's first check out some basics of binary calculations. We are all used to work with decimal numbers with 1 through 10. Basically, that is what we learn in school when you go from first grade and so on. This is easy because we have 10 fingers and we don't have to count out from the top of our head. In binary system, we only have 0 and 1, and this is the language that the computers speak. So if we fill out this table with ones and we do the sum, we add all these numbers together, we will be getting a value of 255. That is the value that we will get after doing the addition of all these numbers. Basically, if we are doing an addition or doing the sum of these numbers, we will get a value of 255, just for you to be informed. Now, let's continue. On the bit on the far left side is called the most significant bit, MSB, because this bit has the highest value. The bit on the far right side is called the least significant bit, LSB, because this one has the lowest value. So, how do we convert decimal numbers into binary? Let me show you an example. If you want the decimal 0 in binary, this means we leave all the bits off, meaning this one as 0 and so on. All of these values are being changed or being added as 0 in all of these spaces. Okay, this is what happened. This will give us a binary value of 0. Because if we sum up all these zeros, we will still get 0. Now, what happened? What happened if we want to have a value of 178, for example? Okay, we will have to sum up 128 plus 32 plus 16 plus 1. And we will be getting a value of 178. This one will be 0. This will be set as 0, 0, and 0. Let's do the sum. Let me just clear the drawing and show you that in fact, if we use a calculator, let me just share with you with a calculator, we will be doing this addition. 128 plus 32 plus 16 plus 2. 178. There you have it. That is the value that we were trying to get. Now, what happens, and I already told you, but what happens when you are doing the sum up of everything in once and everything is turned on? We will be getting the highest decimal value number, which is 255. So let me see if I can open up the application, the calculator, so I can show you. If we are doing the following, if we are doing 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that is 255. As you can see, that is the highest value. whenever you add a bit, the decimal value doubles. For example, you will have the power of 2, the power of 4, 8, 16, 32, 64, 128, 128, 256, 15, 512, 512, 1024, 1024, 2040, and so on. This is called the power of 2. This is a good moment to create your own cheat sheet. Take a piece of paper, use your notebook, and write this table. Write this table so when you're doing the conversion from decimal to binary, it will be easy for you to do this conversion that we have been doing so far. Let's clear the drawings for a moment. Let's move on. Okay, now we need to do the following conversions. We need a 12. So if we turn on this one, and this one is 0, this one is 0, this one is 0, and so on. 0, 0, 0, and 0. We will be getting a value of 12. In fact, let me just use the eraser because some of them, I don't like the way I was drawing that 0. So let me see if maybe I can use something easier. If we are having a, let's just do it like that. Let's just do a 0 here, another one. No, you get the idea, it's a 0. And then this one is turned on, this one is turned on, this one is 0, and this one is 0. There you have it. Let's erase that one because this one, I don't like it at all. Let me see if I can do a better 0 this time. Great. Now 54. How do we get 54? Okay. Let's do the conversion. Let me go ahead. And is 54 higher than 128? No, then it's 0 here. If 54 higher than 64? No, so there is a 0 here. Can we subtract 32 from 54? Yes. So if we do 54 minus 32, what do we get here? Okay, this is 4 minus 2 is actually a 2. And 5 minus 3 is actually another 2. We get 22. So can we subtract 22 from 16? Yes, we can. So if we do a 22 minus 16, we get a value of, we have to borrow here. This one is a as 1. And we get 12. 12 minus 6 is actually 6. And 1 minus 1 is actually 0. So we get a 6. Can we subtract 6 from 8? No, we can't. So this will be a 0. 6 minus 4? Yes, we can. So this will be a 1. And then we have a 6 minus a 4. We get a value of 2. Meaning that we can subtract. So this one is turned on. And we have now a value of 0, which stays here. Let me just use the eraser for a moment. We're almost there. We're almost there. It is actually easier when you have a pen and a notebook. So it is basically the same process. You have to follow along and do the same process. If you take a look, you will see that basically this is a different one. Now let's try other way around. Oh, okay, this is the other way. So we can add the numbers and get the bits here. So we have to add this one plus this one plus this one and this one. It will be, let me see, maybe I can just look for a calculator. I'm going to leave you this as homework so you can practice. If you can draw in your notebook, use pen, pencil, and an eraser and complete this. It will be very helpful for your CCNA studies and to understand the binary. Also, there is a website down below in the class where you can practice with a Cisco game And that is another way to practice conversion from binary to decimal and from decimal to binary. In fact, before I start doing this, let me go ahead and clear the board for a moment. Maybe we can do another one, just a last one, so you can have that one as an example. So we have 187, right? Can we subtract this from 128? No, so this will be, yes, we actually can. I'm sorry, I got confused there. We actually can do it. So 128, so we borrow from 7, this will be a 7, we borrow 8, 9, 10, 11. So what is it? 9, 10, 11, 12, 13, 14, 15, 16, 17. It will be a 9. Let me go ahead and use the calculator just in case so we don't get too much confusion on this and it will be easy. Let me just look for the calculator real quick. But it is the same method. We are doing this subtraction. So 187 minus 128 and we get 59. And we keep adding the ones where we can actually subtract. But if we cannot subtract, we will be adding zeros. The same way, if we want to do it backwards, like from binary to decimal, you have now not to subtract, but you can do it the other way, doing addition. So if we have 128 plus 64 plus 1, I'm sorry, I got it wrong. If we have 128 plus 64 plus 8 plus 2, we get a value of 202. That is the value that we will be adding here, and so on, so on. So what is my recommendation? Practice all of these examples. Try to complete the ones that we are trying to do it right now, and fill out the information. Fill out the information with the ones we are missing. So this one, it was 59, right? What we got from this one, we have this one turned on. 59, we can do 60. Can we subtract from 64? 59 from 64, we cannot do it, so this will be a 0. But what about 32? Can we do it with 32? Okay, so this one is 7, and this one will be at 2. 27. Can we subtract 27 from 32? No, we can't, so it will be a 0. What about 16? 27 minus 16. We have a 1 here, we have a 1 here, we have 11 now. So this one is a 1. And can we subtract 8 from 11? No, so this will be a 0. Minus 4. So we borrow, this one will be a 0. It is actually 4, 5, 6, 5, 6, 7, 8, 9, 10, 11. It will be a 7 actually. It will be a 7 to get 11 minus 4, it will be a 7. So this will be a what? Can we subtract? Now it comes the problem because I think I did something wrong here. 16 give me an 11. I think I'm doing something wrong here. Let me just erase it. We were having 59, right? We were having 59 minus 32, right? So I think that's where the error comes from. I did the math incorrectly. Let me correct this. It was a 7 and a 2. So this one will be a 1. Now 27 minus 16. We have a 1 here and a 1. It will be 11. Okay, this will be a 0. 11 minus 8. 8, 9, 10, 11. It will be a 3. It will be a 3. So this one will be a 1. And can we subtract 3 from 4? No. So this will be a 0. 3 for 2? Yes, we can. So 3 minus 2 is actually a 1. So this will be turned on with the 1 with 2, 1 minus 1. 1 minus 1 is actually a 0. So this will be turned on. That will be the binary value for the 187 and so on. You can do this subtraction. Let me just add the symbol so you don't get confused. We're doing this subtraction. That way, you can continue practice with your pen, your pencil, and your eraser in a chalkboard, and do your calculations and continue practicing binary to decimal and decimal to binary. That's basically it. It's not that difficult. Now, be careful because you saw when I did the calculation incorrectly and I did that mistake. Be careful. Validate at the end. I don't know if there is a section at the end of the book so you can see the correct answers for these. Let me look it up real quick. Let me just clear the drawings. And let me see if maybe in 90, page 90 or more, you can see the validation for this. Let me see, maybe 89. What I want to see is the correct answers for this. Where are they? What about 78? Nope. Oh, we're almost there. We are almost there. 70, 72. There you go. Now we are almost at where we want to get. I'm trying to show you the answers. Answer 3. Okay, we are almost. We got it. We got it. Oh, okay, there you go. This is the conversion. This is the conversion. We're almost there. Where are the answers? Oh my God. Subnet 1. Exercise 1 is actually, this is the one we are looking for. Okay, so you can see in page 60, 61, page 61, the answers. These are all the answers for the conversions from binary to decimal and decimal to binary. So you can see the 202 that we were calculating today. You can see the conversions that we have for 54, for 12, for 54, and for 187 as well. We have the 192, 44, 147. So once you have done your lesson, remember to go to page 61 of the book and validate the answers. You can even pause the recording and do it yourself. Now let's go back to binary just to close this chapter for today. And that's pretty much. At the appendix of this book, we will show you the answers and your result, they are on page 61. So that's pretty much everything we need to learn until this point about binary conversion. I hope that you have learned from this lesson. Remember, practice makes perfect. So it's been a pleasure. My name is Cesar. I will see you at the top of success. So boys and girls, until next time, take care.